Hi everyone, my name is Ryan Crodel with Valencell. I'd like to thank you for taking time out of your busy schedules to join us here this morning or this afternoon or this evening, depending on where you are in the world, to hear a little bit about signs that your biometric wearable project needs help. So before I dive in, a few housekeeping things. We do encourage questions throughout the webinar. Please submit those questions through the webinar interface. And one of the most common questions we get is, will the slides be made available? And the answer to that question is yes. We will make the slides available after the presentation, and we'll also make the recording available through YouTube and other means if you'd like to share this with your colleagues that maybe couldn't make it today. Quick overview of the agenda. I'll go through just a couple of details on how this biometric technology works in wearables, specifically the optical biometric technology, but these signs that a project needs help are certainly not exclusive to optical technology in these biometric wearable projects. And then I'll go through 10 of these signs that your project needs help. This is not an exclusive list by any means, but these are just the most common signs that we see where projects tend to go off the rails. And to that end, Valencell's been involved in more than 40 different biometric wearable product development cycles over the course of the years. And many of those projects started with the company either trying to do it all themselves or using other technologies besides Valencell, and many of those projects came back to Valencell in the middle of the project requesting help to rescue the project. And that's not to say that you can't do this yourself. In fact, to diminish any of the other technology vendors that are out there. In fact, we want more biometric wearables in the market because the more people who experience the value of biometrics in wearables, the better. We believe that this is very much a situation of rising tides lifting all boats. So we want your project to be successful, whether you work with Valencell or you work with someone else. We want to help in some small way make that happen. So with that, these are the most common warning signs we see that you should, at a minimum, evaluate the state of your project. But first, I'll talk briefly for those of you who don't know how this optical biometric technology works. It uses a methodology called Photoplethysmography. I won't ask you to repeat that or pronounce that correctly. I'll just call it PPG for short. Most people do. And how it works is basically shining light into the body and measuring how much of that light is reflected back based on blood flow. You have typically multiple optical emitters here with emitter optics, primarily lensing that goes over that emitter that shines light into the body, and then an optical detector here, typically a photo detector that is also covered in optics and lensing to capture how much of that light is reflected back based on blood flow. Most of these devices today also have an accelerometer or motion sensor of some kind to identify the motion noise that's coming into the photo detector as well. But effectively what it's doing is measuring how much light comes back into the detector and which of that light is based on blood flow to get a sense of what that heart rate looks like and other biometric indicators at any given point in time. So once that data is collected by the sensor, there is signal processing that goes on. We use a methodology called active signal characterization, which proactively characterizes all of those signals coming into the photo detector to be able to identify exactly how much of that light is based on blood flow. That then turns it over into metrics algorithms that take that raw signal and turn that into things like continuous heart rate, RR interval, energy expenditure, blood pressure, other key metrics that you can get off of these optical devices. Those are then turned into more advanced or perhaps more insightful assessments of things like resting heart rate response, heart rate recovery, and a bunch of the other things that you can see there. And then, of course, that data is presented in some form of user experience, whether that's through a smartwatch or a mobile app or a set of biometric earbuds or a fitness band or many of the other devices that are using biometrics today in wearable devices. These are just a few of the form factors that are on the market today. Most of those are either wrist or arm based smartwatches, fitness bands, sports watches, but we're also seeing a tremendous amount of growth in what's becoming known as hearables, where companies are adding advanced sensors like biometric sensors into audio earbuds of all kinds, and whether that's wireless, wired, or more recently there's been a lot of hearables come to market that are true wireless, where there's the buds themselves communicate wirelessly as well as communicating wirelessly to most often a mobile device. So I wanted to do that as an introduction just because that'll set some of the context for some of the most common signs we see that where projects run into trouble. So with that, I will jump into that first sign of a problem, and this is of course very early on in the product development cycle, but if your team or the vendor you are working with does not have a reference design that can at least demonstrate the efficacy of that sensor system for your use case, then that's a red flag. And this is more than just testing on a bench. In the optical sensor world, this is more than just putting your finger over a sensor on a bench and determining if it can measure your heart rate. You need a reference design, even if even if it doesn't resemble what your final ID is going to look like. You need a reference design to be able to show you that this particular sensor technology can work on that specific location in the body, doing those specific things that you expect your users of that device to do. So if the team can't show you a reference design, it's often, not always, but often an indication that the team is in uncharted waters and you might be their guinea pig. And that's not a good position to be in and is an early red flag that you want to look out for in these projects. Sign number 2, and this is by no means meant to pick on Fitbit. It just so happened that this was first reported this week, but it is indicative of many of the early design challenges that we see. And this report is about Fitbit's effort to build a smartwatch, which has been widely reported. But this week, some reports came out that they're having significant challenges in the design, specifically around the GPS and waterproofing, that have pushed out the availability of that device to this fall. When they were originally trying to get this out spring to summer timeframe. And we see this all too often where you can see that in this case the indication that the GPS antenna was not in the right place. And we see that not just with GPS, but a variety of different sensors in locations that are perhaps too close to other modules within the device that cause electrical interference or some kind of disruption in the capability of that particular feature in the device. Waterproofing is a common problem that we see that a lot of companies run into that often delay projects in trying to get, particularly in a prototype format, a fully waterproof design. It often takes more resources, frankly, than a lot of companies are willing to invest in the prototyping phase. But what you're going to find is that you will likely run into waterproofing challenges down the road at some point. So it's better to get it done in the prototyping process and understand exactly how that device is going to get waterproofed before you get too far down the design path. Some of the other common early design challenges we see are in sensor location. So is the sensor positioned correctly in the device itself to optimize the performance of that sensor? And in this case, it's primarily the optical biometric sensors that need specific positioning, and that positioning done in a way that optimizes the amount and the quality of the skin contact, because these devices do require close coupling with the skin in order to get accurate readings off of these devices. Some of the other things we typically see are in the different wavelengths used. This commonly happens in earbuds, where some companies try to use visible light in earbuds to measure biometrics optically. And that works in some situations, particularly indoors, where there's less visible light noise that comes in through the ear and can disrupt that signal coming off of the emitter or coming into the detector. But the challenge then, of course, is if you take that device outside, which many people do, to wear these earbuds outside while they're exercising or just going about their daily activities, then the sunlight tends to wash out, coming through the ear or around the ear, tends to wash out a lot of that visible light. And if your early design does not detect that, or your designers aren't aware of that problem, then you're going to see significant challenges down the road. So those are just a few of the early design challenges we see. Another one is, and this is kind of a corollary to the last one, is around testing. So these devices need to work on a wide spectrum of the human population, and everyone is different, and physiologically and in terms of skin tone and how their body responds to different activities that they put them through. So you need to test these devices on a broad spectrum of the population. You can't just test these devices on your engineers that are working on the project. That device might very well work for them, but it also might very well not work for a majority of your customers once that device gets into production. So you need to test these devices on people of all shapes, sizes, skin tones, fitness levels, you name it. And again, it needs to be tested in using protocols that match your expected user experience. So those protocols sometimes involve sports and fitness. Sometimes they involve more lifestyle activities, like just typing on a computer or doing dishes or just walking down the street, whatever it might be. But another problem we see is that the amount of testing done, not just on a diverse population, but also in terms of the prototyping process. It's very important to have an iterative testing and development process where you test every version of your prototypes, no matter how small or how insignificant you think the changes might be to that prototype. Every version of that prototype should be tested with that level of rigor. And we typically see a need to test on at least 20, preferably 30 people per testing cycle, again, assuming there's a diverse set of physiological factors and demographic indicators in that population, to be able to make sure that that device and that any of those changes any of the changes in the prototype have not had an adverse impact on different portions of that population. So with that, we'll move on to the next one. This is a fairly common problem we see, or common refrain we hear around Well, the signal coming off of the sensor is not as clean as we would hope, but we'll fix all of that in the algorithm. I showed earlier that kind of flow of the data flow diagram from the sensor all the way through to the metrics being measured and the assessments off of those metrics. The hardware and the software in these devices work best when they are designed to work together. So if you're using a set of hardware and a set of software, firmware, and algorithms that from two different companies or multiple companies, then you have to be very careful because the algorithms have to be tuned to the hardware design and specifically the optomechanical design and how that data is coming off the sensor in raw form, and then how that feeds into the algorithm. You can have the greatest algorithm in the world, and it still won't fix bad hardware or an unclear signal coming off of hardware. And actually, vice versa, you can have the greatest hardware design in the world. If your algorithms aren't designed and aren't optimized to take in that signal off of that hardware, you're going to run into challenges. And the nature of those challenges will vary, but you can't just say, or if your teams are saying, oh, we'll just fix that in the algorithm, or we'll just fix that in a hardware change, that's not as easy as it sounds. And that leads to the next sign, which is something that we like to call the whack-a-mole problem, which is you have fixed one problem, let's say it's in the hardware, and you make that hardware change, which it could be even a hardware change unrelated to the biometric system, but let's say you make a hardware change that's designed to improve the quality of the signal coming off of the sensor. You can see that the signal quality has been improved, but then the resulting quality of the biometrics coming off of the device, i.e. Coming out of the algorithms, don't look any better. In fact, they can look worse in some cases. And so we see this very often where you'll fix one problem, and this is particularly problematic when you're dealing with multiple vendors for the hardware and software. This can lead to fixing one problem, but then one or multiple other problems popping up that you've got to deal with. And so if you're using multiple vendors, this has a bad tendency to lead to a lot of finger pointing and to people not wanting to, and maybe not seeing the complete picture of a system-level view of how all of these things are working together, and therefore aren't able to solve those problems effectively or perhaps causing more problems, even though they might fix the one right in front of them. This unfortunately leads to what we call and what we see quite a bit as just another couple of weeks trap, where some of the consequences we see of new problems popping up that don't appear to be all that challenging, or there appears to be a clear path to resolving those challenges. But of course, when you resolve that one challenge, then there's a likelihood that you'll see several other challenges pop up in its place, where you'll say you or your team will get the impression of, oh, we just need a couple of weeks to fix that issue, and then we'll be good to go. And then, of course, that leads to other problems, which just another couple of weeks beyond that, and so forth, until your project is delayed and or in jeopardy, and you don't have a clear path to exactly when all of those problems will be resolved and how you can get to mass production ready product in the time frame you expect. Another sign is something that we call the disappearing features phenomenon, where let's say in the original spec of the device you had a grand plan for 10 features to be delivered, 10 primary features to be delivered in that device. And let's say from a biometric standpoint, this could be things like continuous heart rate variability, cardiac efficiency, and other capabilities along those lines. And what we see all too often is as these projects move along, as the testing process goes forward, then the efficacy and the accuracy of the device is not where companies expect it to be, and those features, especially some of the more advanced metrics, the more complicated features that provide better insights and better user experience in what's going on in a user, those features start to drop off as the features or as the accuracy of the device is not meeting expectations. And so if you start to see, this is kind of the opposite of scope creep. If you see the scope of the device shrinking because throughout the product development cycle, it's a sign that you again need to evaluate the status of that project. And similarly, what we see, and this leads into the next sign of a project potentially being in trouble, is when those features start disappearing off of the spec sheet or off of the capabilities of the device. Often what happens is companies will say, okay, we'll do that in the next version of the device. So they push that out to those features out to the roadmap and focus on what they can do with the device, even though that's a diminished user experience for that particular device. So we see those features often get pushed out into the roadmap, but then the same thing happens over again when the first device may get out to market. It may be mildly successful. The companies look at a second device or a follow-up device, a version 2 of that device for their roadmap, but then recognize that the capabilities of that original device are not able to support that roadmap. And it's not going to just take a few more months or a few more weeks to be able to pull those roadmap items in. You will then often start to see the roadmaps shifting significantly in terms of the capabilities. Now, of course, roadmaps always shift, and they are that's not uncommon. But when you start to see a pattern here in terms of the capabilities of these devices and the plans for future devices diminishing rapidly as the product development cycle goes on, you may need some help there. Sign number 9 is something that we've seen over many of these projects, where it's something we call the FiveMonth Threshold, where if you don't have a ready for production prototype within or by 5 months before your scheduled launch date, you very well may have a problem that's going to cause that launch date to slip. And nobody likes slipping launch dates, of course. You want to get the project right, and you want to get the right product into market, but you also have to minimize the schedule risk. And if you're at the 5-month point away from your launch date and you still don't have a device that works as well as you expect it to and doing all of the things that you expect it to for your users, you need to really evaluate that project and take a look at either moving that launch date or revising the capabilities or getting help in fixing that product and getting that product out to market on your scheduled time frame. It's of course not an easy decision-making process, but we've seen typically at that 5-month point, companies that's a make or break point where if you don't have it, have a production-ready prototype by then, you're very likely in trouble. So build your schedules accordingly. towards that 5-month threshold, and that'll keep you in good shape. And that actually, a big reason behind that 5-month threshold is the manufacturing process. So it's all too often significantly underestimated the amount of complexity that adding biometrics to a wearable brings, both in the manufacturing and the scaling process. So if you're building a biometric wearable for the first time, and so everybody has a first time, so that's nothing wrong with that, but you also want to be aware of your manufacturing partners, your ODM or contract manufacturer who is building the device. If they're building a biometric wearable for the first time, that is a concern. Valencell, as I said, has been involved in many of these different projects, and we've years ago recognized the need to create a certification program for contract manufacturers in building biometric wearables. So we have gone and actually have a team here that maintain that certification program to teach those contract manufacturers how to build biometric wearables appropriately. And we maintain that level of certification. We do in-person inspections in those facilities and with those teams to make sure that they are maintaining their capabilities, because you will inevitably run into manufacturing challenges when you have to build in lensing appropriately. The angles of the LEDs are important. The geometry between the emitters are all important. Emitters and detectors are all important. All of these things are critical components in a manufacturing process, and the devices that come off the line, of course, need to perform as well as your prototype in the lab is performing. And so another step that Valencell has had to take in this process is creating a test jig that sits at the end of every production line that we work with, that tests the accuracy of the optical sensor modules in those production devices, to make sure that every one of those has that same level of performance as what we saw in the lab. These are things we've learned over the years, and if you haven't been down this path before, you're inevitably going to run into these challenges. So I would encourage you to work with a manufacturer who has built a biometric wearable similar to the one you're building before, because you don't want to have to go through all of their lessons learned in addition to all of your lessons learned in the design and prototyping cycle as well. So with that, that's all of the prepared material I had. I wanted to keep this one relatively short and to the point, and so I wanted to see if there were any questions and it looks like there was a question about no audio. Sorry, I missed that at the beginning. Hopefully that was not the case, and you were able to hear everything I've said so far. Another question that came through was around the capabilities of the optical sensors in measuring different biometrics and different assessments, and how it goes about doing that. So there's the raw signal that comes off of the sensor that gets turned into what's known as a PPG waveform. This is similar to the EKG rhythm that you see in medical devices. And off of that PPG waveform, you can get a variety of different biometric indicators, not just continuous heart rate, but it allows you to, and this is a big reason why optical is being used in many of these devices, is because of the variety of biometrics you can get off of the same sensor hardware or sensor module. And so that's things like energy expenditure, things like VO2, which is a way of measuring the body's ability to process oxygen. You can get things like RR interval, or the time between beats of the heart, which can be turned into an assessment called heart rate variability. And heart rate variability has a variety of different uses, both in sports and fitness use cases, as well as lifestyle and more personal health and medical use cases. It's a proxy measurement for stress on the body, whether that's physical stress or psychosocial stress or some other level of stress on the body. So, and those, of course, those metrics are processed by algorithms that then produce a number or stream of numbers that can then feed into additional algorithms to do those assessments that get to some of those more advanced analytics and biometrics. So it looks like that's all of the questions we had come through at the moment. If there are any other questions, please do submit those through the webinar interface. I'll give that another minute or so so people can type their questions in. In the meantime, if you think of questions after we're done here, or if I can help in any way in your biometric wearable project, please don't hesitate to reach out. That's my contact information, and would love to hear from you. And at this point, I'll just say thanks again for taking time out of your busy schedule to join us here today. I really appreciate it and know how busy everyone is. So taking even a half hour out of people's schedules is very much appreciated. Hope you found this valuable. I am not seeing any other questions come through at the moment, so I'll go ahead and wrap up and say, if you do have follow-up questions, please do reach out to me there. Once again, we will make the slides and the recording of this webinar available through the Valencell website, and we'll send that out via email as well to everyone who participated and who registered for the webinar. So thanks again, everyone. Have a great day, and we'll be in touch soon. Thanks.